This is our first video on Chapter 10, which is probability. Now, before we even get to probability, the first thing we have to do is learn how to count using different scenarios. So this first slide here is called a fundamental counting principle, and it's the most basic setup of most of our counting. So in this video, our objective is to review different counting principles that we will use in order to set up later on probability problems. So this whole lesson is just dedicated to this counting. So let's take a look here. If we have a scenario where how many different meals can I have, including a meat, a side, and a dessert? Well, over here we have three main side dishes, or main dishes. There's your meats. We have two sides, mushrooms and fries, and we have three desserts. So you have, you can pick three things, a meat, a side, and dessert. How many different ways you can do that? Well, if you look at the example here, I'm going to go to a full screen. Here's basically a tree diagram showing everything. So notice if you pick a hamburger, you could then pick mushrooms, and then you could pick an ice cream cone. And that's option number 2. So if you actually visually spell them all out, you notice there's 18 different options that can happen here. So instead of writing them all out every single time, is there a better way to count the scenario? Well, sure. What we do is we say, okay, if there's three main meats and there's two sides and then there's three desserts, you can simply multiply those together, 3 times 2 times 3, and notice we get 18 different options. So basically what we're doing is having, three blanks for three different picks, and we put down the number of options in each one. So for every one meat, there are two options of this, and you do that 3 times, and that's why we multiply what we have. So that's the basis of our counting. Now, this next slide here, we have different counting principles that we have to be aware of. Notice the ones that are stars. Those are things that are similar. They're very fundamental what we do. The one with smiley faces, those are ones that are special cases that kind of coincide with these similar and fundamental ideas. So we use a lot of times the smiley faces for special cases, but again, they're all kind of related back to the star ideas. All right, so first one, fundamental counting principles. That's just what we did with the first slide, counting. And again, that kind of goes with the blanks here. Now, we're going to use the blanks a lot of different ways to show different scenarios. So all else fails, you want to use the blanks. So we'll see examples of this. Again, I'll go through examples for all these either in class or in the examples in this slide here. But this is a good slide to show everything. Then we have permutations, and notice what it says. The number of ways our objects can be ordered taken from a group of n distinct objects. The key here is that order matters for all of these, and what we want to do is, this is a special formula. We're going to have a special slide just on that, so we'll take a look at that in a second. Then this next one is indistinguishable objects. If you have, for instance, counting and there's a repeat, then you use this equation here. So this is for repeats. Next one, circular permutations. This is where there's no start and there's no stop, and you have a circle, but order still matters. So we use one of these two scenarios here. We'll do a demonstration in class to better explain that, but again, these are the two formulas we want to use. Then circular permutations, if you could turn upside down, this is like a bracelet scenario, things that can be flipped upside down. How do you handle that? Well, you use this scenario right here. Okay. So again, you want to come back to the slide and as far as a reference for different principles here. So let's take a look here at the first one. Now this is factorial. This is where n to the factorial power. And here's a spelled out equation for what happens. But really what it's happening here is if we say 5 factorial, that means you take 5 times 4 times 3 times 2 times 1 all the way down till you hit 1. And what do we use this? Well, in a situation like this, how many different orders can I put the letters A? How many different orders can I put the letters A, B, and C? Well, notice over here I have actually drawn out all the different orders for A, B, and C. Notice we start with A, and then we can do B, C, and I can rotate to B and C. Then I can start with B and do the same thing, rotate the other letters. So here's all the different possibilities to order those three things. So another way to look at it is using blanks. We say, okay, let's say you have like three Scrabble pieces and the three letters A, B, and C. How many different options are there to start off with? What is three? Well, once you pick a letter, let's say for instance we pick A, then you look, okay, for the next position, how many available letters are left? Well, if we already picked A, there's only two letters left. And if you put A and then B, how many letters are left for the last spot? Only one. And notice this coincides with factorial. So that's why we use factorial in these situations, where this is a basic permutation where you use all the options and you start and you basically put any type of objects in order, first to last. Okay, so we're going to use that as factorial. Now, what happens is we have this thing called permutations, and notice the P here, and this is a thing that we're going to see on the calculator. Okay, and we'll show that on the calculator here in class. So right now I'm just going to show you some examples of what we're going to do. Now, what happens here is, let's take a look here. How many different ways can five runners finish first, second, third place? Well, if we do it using blanks, there's first, second, third, and it's a total of five runners. Well, if five runners are eligible for first place finish, and let's say, Bob crosses the line, well, there's only four people left that are still racing that are fighting for second place. And after second place is figured out, then there's three people left fighting for third place. Now notice we don't care about the last two people, how they finish. We just care about first, second, and third. So notice this is like 5 factorial, but we don't have the 2 and 1. So how do we show that? Well, we use this equation up here. So on the top here, we have 5 factorial. And on the bottom, we say, okay, N is the number of people racing. So that's the total number. And then R is the number of positions in this case. So in this case, we have 5 people running, but we want 3 positions. So we do 5 minus 3 factorial, which inherently is 5 factorial over 2 factorial. Now let's take a look to see what this looks like. 5 times 4 times 3 times 2 times 1 all over 2 times 1. Notice here, the 2's cancel, the 1's cancel, and you're left with this 5 times 4 times 3, which is what we did when we did our logical setup here. Okay, so in order to get the setup every single time, we use this formula, NPR. Okay, and a lot of times we refer to the P as pick in our vocabulary. Okay, so basically it's 5 times 4, um, which is 20 times 3, so there's 60 different ways that you can pick a first, second, and third place finish using 5 racers. Okay, so that's a quick way to count there. So that's called permutations, and again, when you have a select number of positions. Okay, so here's some different examples that we will practice in class, using a calculator. So 6 factorial again is 6 times 5 times 4 times 3 times 2 times 1. And so forth. And notice down here we have number 5. When I read this, this means there's 4 total options and we want 2 positions. So it'd be 4 pick 2 is the way we would say that. So we'll show how to use this on the calculator in class. But here's some examples of different ways to show counting. Okay. All right, so here we have a couple examples. I'm just going to do a couple select ones to show you, and we will cover the rest of them in class. So let's take a look here. Let's do number 6 first. How many different ways can 9 books be lined up on a shelf? Well, if you think about it, if you have literally 9 positions, that's 4, 5, 6, 7, 8, 9. I think that's 9. 2, 4, 6, 8, 9. So let's say you have a stack of 9 books. Well, there's 9 options for the first position. You put a book on a shelf. Then there's 8 books left, 7 books, 6 books, all the way down to you get to 1 book. Okay. Again, a better way to write that, 9 factorial. Okay. So again, on the calculator, we'll calculate these all. Right now, I'm just going to focus on the setups. Let's look at back to number 1. How many different 4-digit numbers can be used? Only the odd digits if repetition is allowed. So let's take a look here. If we have 1, 2, 3, 4, there's a 4-digit number. Okay. And you can only use odd digits. Well, there are 5 odd digits. Okay, we're talking 1, 3, 5, and all the way up through 9. Okay. If repetition is allowed, well, once you pick a digit like 3, then you pick the second digit. Well, again, repetition is allowed, so any one of the 5 odd digits that's available. So we simply just repeat 5 4 times, and we can simply say 5 to the 4th power. Okay, so notice I'm using blanks here to set up these a problem initially, and I'm going back to my different weapons or tools on how to set these up. Let's look at number 2 here. The class has 25 students, and the students must select a president, VP, and secretary. There's 3 positions. There's the president, there's the VP, and then there's the secretary. And we're going to multiply these. There are 25 students to start. Once you pick a student, you can't be president and VP, so there's only 24 students left, then 23. How do we write that using our calculator? 25 pick 3. Okay, so of the 25 people, we're picking 3 people. Okay. Find a number of permutations in the word arrangements. Now let's take a look here. This is just like the book problem above where we're arranging different letters. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 different ways to arrange those letters. But notice we have some repeats like the A and A. If I switch those A's, nothing happens. So we have to divide that out. And we'll talk more about this in class. But the setup, looking back at your weapons sheet, is to take out that 2 factorial because there's 2 ways to arrange those A's. And then you have 2 R's as well. So you do it for the R's. And then any other, you have 2 E's. So that is the setup for permutations when you're arranging when you have repeated items. Okay, I'm going to go ahead and do 3 and 8 here. How many different 3-digit numbers only have even digits? So 1, 2, 3. Even digits, again, including 0. Now let's take a look here. If we're talking about numbers, typically numbers don't start with 0, so there's only 4 options, 2, 4, 6, and 8. But then you can have 0 in the second position here, so we're going to say there's 5 options for this one, and then 5 options for this one. You simply multiply those together, so we're going to get 100. Okay, so that one notice we can do in our head very easily. These other ones we're going to use our calculator. Okay, and the last one here. John has 3 pairs of pants, 5 shirts, and 2 pairs of shoes. How many different outfits does he have? Well, we have pants, shirts, and then shoes. And we just go back. There's 3 pairs of pants, 5 shirts, and then 2 pairs of shoes. Simply multiply those together, and he has 30 different outfits that he can wear simply with those articles of clothing. Okay, so that's what we have here. A little introduction to counting. I'm going to have you go ahead and why don't you guys try 4, 9, 5, and 10. Try those for class tomorrow, and then we'll debrief a little bit more about each one in specific case. But I want to make a shorter video here that kind of reviews all the different scenarios.